Okay, part two of the instructions are going to be, this is going to be finding asymptotes and some kind of, it's going to kind of help you learn how to graph these things too. So basically for finding asymptotes and for graphing, we're going to want to draw what I refer to in the notes as a magical rectangle, which may be a little bit confusing if you don't know what I'm talking about. But basically what it is this. I have an equation, x squared over a squared minus y squared over b squared equals 1. And this is the equation of a hyperbola centered at the origin, because x and y are not, there's no number subtracted from x or number subtracted from y. And that means that the origin, and because x squared is positive, it's going to open to the left and to the right. That's going to be an important thing for you guys to be able to identify at the outset of these problems. Does it open left, right? Does it open up or down? The way to answer that question is, which one is positive, x squared or y squared? So because x squared is positive, it opens left and right. And now the question is, how are we going to graph these things, / how are we going to find the asymptotes? And the answer is we're going to use this rectangle. And we draw this rectangle by starting at the center, and we're going to go a units to the left and right. So that's going to be like over here. This would be a. This would also be a. And then we're going to go b units up and down. We haven't used b yet, but let's say b is, I'm going to pretend like b is bigger than a. Doesn't really matter. We're going to go up and down b units. Then we're going to draw a rectangle where like the top and bottom are going to be these points, and the two sides are going to go through these points. Let me show it. I tend to draw this as a dotted line because this rectangle is not actually part of the hyperbola. It's just like a box we use for reference. So drawing that rectangle is really important because it helps us graph them when we get to the graphing part, and it's going to help us find the asymptotes. So the asymptotes are, as before, lines which as x goes to positive, negative, infinity, they're lines which the graph of the hyperbola gets closer and closer to. So you draw them, I always draw them dotted as well because they're not actually part of the hyperbola, but they look like this. And this. So you can see my hyperbola, the graph kind of sucks. Now that I have the asymptotes, I can draw it a little better. I'll do that by starting here, and then I draw this so that it gets close to the asymptote. That's pretty much how this is going to look. And I'll be fairly generous as long as it looks like it's getting approximately close to the asymptotes. It's gonna be fine. But this is basically how we graph these things. I'm gonna do the next example. I'm gonna do the first example in the notes in just a second with numbers, so you'll see exactly. But the way that we're gonna find the equations of the asymptotes is we're going to use this equation, which you all might recall, probably seen it before. General equation of a line where n is the slope and b is the y-intercept. And this is what I meant before about saying when they're centered at the origin, it makes the asymptotes easier. Because when the hyperbola is centered at the origin, like this one is, you can see that both asymptotes go through the origin, which means b is going to be 0 for all these. So to some extent, we can imagine I'm not going to ever have to worry about b. It's always just going to be 0. So all I got to do is figure out what m is. And if I think about the way that I drew this box, I went up b units and over a units to get this corner. And since this line goes through the origin and through that point, up b and over a is the slope of that line. So one of the asymptotes, the equation is b over a times x. Again, slope, rise over run. I went up b units and over a units. And that's what this is going to look like. Slope, b is 0. This b is the y-intercept b. Ooh, this is a little confusing. Y equals mx plus b, we've always used that equation, and this b stands for the y-intercept. Don't mix it up with this b, which is a different thing now. This b has to do with the size of this rectangle. This b and that b are not the same. Luckily, we're crossing that off every time anyways. So if I think about, that was just this one asymptote. If I think about the equation of this other asymptote, I'm going to do it in a similar way. To get from this point on this line to that point, I went down b units and over a units. So that's like negative b over positive a. So that's going to be negative b over ax. So one equation has a positive slope. That's going to be this one. One equation has a negative slope. That's going to be this one. These are going to be the two equations of my asymptotes. Some of you might say, hey, can I just write it like this? The answer is sure. You can memorize this, but when it's oriented like the other way, where it's an up-down hyperbola, it's going to be a over b, and I don't want you to get too confused with that. It's fairly straightforward if you draw this rectangle to then just say rise over run, b over a. The other ones might be a over b, that's why I'm saying maybe don't memorize this. I'm going to do the two examples in the notes, and you'll see exactly what I want you to do for all these problems. So that's going to be the next two videos.